start off the circuit analysis course by introducing one of the most fundamental elements of a circuit, which is called the charge. Now, to explain what a charge is, I'll just use an analogy. Imagine this, that there are some houses in a colony, like 3 houses for example, and then there's a postman who is delivering letters to each house one by one. Now, this postman is what a charge is in a circuit. The letters he's delivering, they are the energy, and these houses, they are the elements, the circuit elements. So this is how you can define a charge. A charge carries energy in a circuit. Now, the second very important quantity is the current. I'll just use the same analogy as before. Imagine this, that there's not just one postman delivering the letters, there are a bunch of postmen. So each postman has a different speed and he's just delivering some different amounts of letters. So imagine this, that if you take a point in their path and you see the number of postmen passing through that point per second, that is what the current is. So current is basically the number of charges passing through any point per second. So this is what the current is. Now, after defining both of these quantities, let's see, like, both of these are mathematical quantities, so they must have some mathematical units. So the unit for charge is basically the Coulomb. This is how you can define a charge, and the symbol is Q. The unit for current is Amperes, and the unit is A. The abbreviation is A. So this is what charge and current is. Now, another issue arises because if any one of you are familiar with the concept of physics, there are actually two types of charges. There is the positive charge and then there is the negative charge. The positive charge is basically the protons, for example, in atomic structures, and the negative charges, they are the electrons. So what charge is it that is traveling through the circuit? Is it the electron or is it the proton that we measure? So the thing is that even though electrons are the one that move around a circuit, we still use a convention or a rule that we will use the protons in all our calculations. Now, even though this sounds a little ambiguous, but using either one of these, that won't make a difference. But this is what we basically usually use, which is called the convention or the conventional current. So now I'll just show an example. Imagine this, that there is a wire and this wire, and imagine this, that there are 5 ampere of protons traveling from left to right. Now 5 ampere means that there are 5 protons per second that are traveling from left to right, or 5 positive charges per second. So the current, this is the current. But if you want to know what the direction of electrons is, just remember this, that in any wire or in any circuit, the direction of both of these charges, they are opposite to each other. So if someone asks you that, like, what is going on with the electrons in this wire, so you can just say that they are traveling from right to left with the same current. So this is how it works. I'll just show another example now. Imagine this, that you have a wire and someone tells you that electrons are flowing from left to right with a rate of 6 electrons per second, and you have to find the current. So you know that there are electrons basically traveling from left to right, and their rate is 6 electrons per second, or 6 charges per second, so it should be 6s. But the current is always used with the convention that we need to see where the protons are going, and because electrons are moving from left to right, the protons, they must be going from right to left in the opposite direction, but the rate would be the same. So the current is basically 6 amps, and current is a vector, it has a direction, and the direction is right to left. So this is how charges and current works, and I hope this has made the conventions a little more clear.